and you'll submit your exam on Hawks. You will scan those papers in to me. You upload it in the assignment box on Blackboard, and then as they come in, I will grade them and release them back out to you. And that's it. So before we actually start working, are there any questions on the exam itself, on how it's going to be played out or anything like that?
Is it going to be like the same amount of questions sorted to the review?
Yeah. If you happen to have looked in the review stuff folder on Blackboard, I put the review answers, the formula sheet. I also put an old exam up. And that old exam is going to be very similar to the exam that you're about to take tomorrow. So it's going to have, I think it was like 20-ish, 19-ish questions. I can't remember. But yeah, it's going to be very similar. Okay. All right. Anything else about the test or about the test times or anything like that? Okay. So then I want to show you something real quick, just in case you haven't already looked on Blackboard. So bear with me for 1 second here. You should be able to see my screen, and I'm in Blackboard now. And in case you haven't looked, if you scroll all the way down to the bottom here where it says Unit 4 review stuff, and then it says Unit 4 exam stuff, if you click in the review section or in the review folder, here's what pops up just in case you haven't. There are 4 worksheets that contain extra help. The first one is on domain and range, then odd, even, and neither, and then transformations, and then graphing transformations. So if you're struggling with any of these, take a look at these. The next section you see is the Unit 4 review. The first click or the first link is the formulas. The second link is a blank review, just in case you want to look at it. And then the third link is the review key. Here's an old exam. I don't know if you're gonna be able to see this or not, but maybe. But if you look at the old exam, you're gonna be expect to see exactly that with new numbers, okay? And on that old exam, there was a total of 22 questions. So the one that you're gonna take tomorrow is gonna be very, very similar. Now, when you go to turn it in, you're going to click back down on the last folder where it says Unit 4 exam stuff. And I haven't created it yet, but there's going to be an assignment Dropbox right there. That's where you're going to submit your test. Okay? Any questions on this? All right, then let's go ahead and we'll get to the whiteboard. I'm going to turn my camera off and let you guys see this whiteboard. And if you need something, just chime in and ask me. I'll check the chat every once in a while. And basically what we're going to do is you guys have reign of what we cover. And I am going to just ask you which questions you want to see me do, and I'm going to do them. So go ahead and get that out if you have it or however you've written it down. And we will get to that. All right, so can we see the whiteboard?
Yes.
Yes. Okay. All right. So looking at the review, I already had somebody ask me for number 1. So that's where we're going to start. Okay. So we're going to start with number 1. And if you look at number 1, actually, let me see something here. Can you guys see this now?
Yeah.
The review key?
Mm-hmm.
Okay. All right. So if you look at number 1, let's look at it like this. Over here, they're giving me this graph, and it's just a parabola, and it's asking me to list its domain and range. And then it wants to know, hey, is this thing a function? And so as we had talked about domain and range in the past, domain is just the x values. Okay. It's the x-axis. And so we ask ourselves, how far does this thing go left? Well, if we see these arrows down here at the bottom, sure, it's going down all the way, but it's also going to the left all the way. And it's also going to the right all the way. So as a whole, how far left and right is this graph going? That's how I'm getting negative to positive infinity, or all reals, whichever you prefer to rate. Now, as far as the range goes, the range, of course, is how far up and down, which is the y values. And so if you can see this teeny tiny little mark right here, this is the highest y value I have, which comes from the vertex. And then I start at the origin. I say, okay, how far up does this thing go? Well, it goes 1, and then it goes 2. And so how far down does it go? Well, these arrows are telling me to go down forever. And so my range is going to be from negative infinity all the way up, including the number positive 2. So there's my domain and my range. Now, step 2 wants to know, is this relation a function, yes or no? And so we have to put it through the vertical line test. And so I can draw a vertical line anywhere on this graph, and it's only going to cross through the picture of the graph 1 time. And so, yes, this is a function. Done. Better on 1.
Yeah, I was doing the other test, the horizontal one, not the vertical, and I think that's where I messed up.
Okay, yeah. So if we're trying to just find if it's a function, it's the vertical line test. If we're trying to find does it have an inverse, that's the horizontal line test. Okay. All right, so what's next? So we did 1.
what would make that the domain not all
Not all real numbers?
Yeah.
Okay.
How would you know? Like, why
Okay,
wouldn't
so-
you?
Let's say here's the picture, okay? And let's say that I have like a rectangle. All right. And let's say this is -3, and we'll say this is +3, and this is 1, 2, 3, 4. This is 4, and this is 2. Okay. And so we're looking at this picture, right? And I need to find the domain, and I need to find the range. When we talk about the domain, we're only looking to see how far left and how far right. Let's see, can you work through 2? Yeah, I'll do 2. So if we're looking at the x's, which is just the left and the right, I'm only looking at this x-axis right here. And so I look at this picture and I say, okay, how far left does this picture go? Well, clearly it stops right here. It doesn't go any further than right there. What is that x value? -3. So we're going to put a bracket. We're going to put a -3. We're going to say, okay, well, how far to the right does this thing go? Well, obviously it stops right here. What is that x value?
3.
+3. So there's my domain. And so now when I look at the range, I'm only looking at how far up and down this thing goes. And so I ask myself, okay, what is the lowest y value in this whole entire thing? And so I look and I see, hey, well, it goes, starts at 0, goes up 1. What is this number? 2. So the range starts at 2. And then how far up does it go? Well, 3 all the way to 4. And so here's my range.
Okay.
Okay, so that's how we're going to know.
Okay, so when it has like the arrows, since it's a parabola,
Mm-hmm.
and it has the arrows, that means it's all real?
As far as the domain goes, yes. Because those arrows, what they're telling me when I see a parabola like this, these arrows are telling me that it continues in this manner forever. And so in addition to going all the way up forever, it's also going to get fatter and fatter. So it's going to be going to the right and to the left each direction forever.
Okay.
Okay, and so when we have a square or rectangle or some shape like this and it doesn't have those arrows, this little guy right here is contained on that graph. He's not going anywhere.
Okay.
Okay?
So you could put negative infinity to positive infinity or all real.
That is correct, yes. All right, I'm gonna turn you guys up a little bit. There we go. Okay, so let's do the next one that I had was number 2. So let's take a look at number 2 and see what it's about. It says, it gives me this function. It gives me g of x equals -2x squared minus 3. And it says find g of x minus 1. Okay. And so what are we going to have to do with this x minus 1 business? Where are we going to have to put it?
Plug it in for x?
Yeah. So I'm going to have to put it here and here. And so I'm going to rewrite this as g of x minus 1 equals -2 times x minus 1. That whole thing is squared minus 3. Okay. So now for the time being, I don't really care about these guys anymore. I'm focusing on this guy. And so now because this guy's being squared, what's the first thing I'm going to have to do here?
FOIL.
Yeah, FOIL. So my -2 just hangs out. This is going to become x minus 1 times x minus 1. This little minus 3 just hangs out. And so now I'm actually going to go in here. I'm going to FOIL. So my -2, again, just chilling. So x times x, x squared. X times -1, negative x. -1 times x, negative x. -1 times -1, positive 1. And then my little -3 still hanging out. Now, in order for me to get rid of these parentheses, I'm going to have to take this -2 and distribute it throughout. So I'm going to do that. So I'm going to come over here because I'm running out of space. I'm going to have -2x squared plus 2x plus another 2x. Let's see, -2. I'm running out of space here. And then my -3. And so as always, when I get something that I can simplify, I absolutely must. And so I look at this and I say, okay, there's only one x squared value. So negative 2x squared. These guys are my x values. I'm going to add them up and get positive 4x. And then these guys are my whole numbers. I'm going to add them together and get -5. And this is my final answer. All right, what do you think about that?
That wasn't as bad as it looked.
Yeah, it's not as bad. It's just plugging in whatever they give us, simplifying like we already know how, and then saying, okay, done. That's it. All right, let's see. Easier than I thought. Yeah, so not so bad.
Do you have to write that one as g parentheses x minus 1, or g of x equals the -2x squared plus 4x minus 5?
So you mean from like my final answer?
Yeah.
So what I would do is I would just write g of x minus 1, right, equals hold on, I don't know why I put 2 parentheses there, equals, and then my negative 2x squared plus 4x minus 5. And that will be perfect. And even if you don't have this, I'll know. Okay, all I really need is this for sure. Okay. All right, better on this was number 2. Anything else on number 2 before we do a new one? All right, so then someone asked me to do number 3. So let's take a look at that. Okay, so number 3. Let me get my page here. Hold on, I'm having an issue, of course. All right, number 3. It says, okay, 14. I'm writing on the list, so I got 14 added to my list here. Okay, so number 3 says, determine the implied domain of the following function. And I get f of x equals, and then I have the square root of, and underneath of that is x minus 7, and on the outside is also a minus 7. And so the problem here is I'm trying to find a domain, and we had talked about the domain before about how we have 2 rules, so to speak. And the first rule is we have to look and make sure that there are no fractions with a variable on the bottom. So do we see any fractions with a variable on the bottom?
No.
And then we say, okay, well, second rule, do we have a square root symbol in our problem?
Yes.
Yeah.
Yeah. And so that's what we have to deal with. And so we know that we're only concerned with this. And what do we know about the stuff under the square root? It has to be what?
It has to be greater than or equal to 0.
Exactly. And so then I'm going to solve this by adding 7 to both sides. And I'm going to get x must be greater than or equal to 7. So this is my answer, so to speak. But since the problem asks you for an interval notation, I like to put it on the number line first. And so if I say greater than or equal to 7, that means I'm going to start at 7. I'm going to draw a bracket, and I'm going to shade to the right. All the way. And so for my final answer, I need interval notation. Well, the interval is right here. How far left am I going? 7 with a bracket. How far right am I going? Infinity. This is my final answer. So when you're taking the test and when you're doing the work, don't just leave it as this, because while you're totally correct, it's asking for interval notation. So you have to make sure you put it in interval notation. All right. Any other questions on 3? Is that better? Okay. So now somebody asked for number 4. So let me get back to my page here. Number 4, if I can. All right, number 4. It says consider the following relation, and it's giving us a set of points. And so the set of points that we have 3, 1, and we also have 4, 0, and we have 3, 4, and we have 0, 4. Okay, and so this is the set of points that they're giving us. It's just some type of relation. And question number 1, or step number 1 rather, asks me for the domain and the range. You know, we can't overthink this. When we first talked about domains, the domain is which value?
X.
X. And so I'm going to look through here, and I'm just going to list the X's. And so I have a 3 and a 4, and oh, hey, look, another 3. Do I have to list those numbers twice?
No.
No. And then so I move on and I have a 0. Okay, so there's my domain, those 3 numbers. And then when we talked about domain and range at the beginning, we know that the range is the Y value. And so I'm going to make a list of my Y. So I have a 1, and then a 0, and then a 4. And then when I get to this other 4, oh, it's the same number. So I don't want to write it twice. And so there I go. There's my domain, and there's my range. Now, step number 2 is my guess as to probably where we had questions. Because it says to determine if the relation is a function. If it is not, identify 2 ordered pairs as proof. So I want to draw a graph real quick. Just watch. Basically, what we're saying is this. We have points that would give me this picture, let's say. Okay, I don't know. Let's just say. And we had talked about when we had a function, if we were to draw the vertical line, it can't have 2 x values, because that means, hey, look, this is not a function. And so when all I'm given is a list of points, that list of points cannot have the same 2 x values. So are there any points over here that have the same x values?
Yeah.
Yeah, which ones?
3, 1, and 3, 4.
Yeah. And so what we're going to do is we're going to write no, it's not a function, right? And then we're going to say, okay, well, here's my proof. 3, 1, and 3, 4. And now I'm done. Okay, so think about that for a second. Let me know what you think, because that one should be, pretty straightforward. So we did 3. Okay. That was 4 already. Let's see what's going on in the chat here. Okay. All right, I can't for some reason. All right, let's see. 7, 6, 7, and 8. Okay. 6, 7, 8. All right, we'll just go in order. We'll do 6 next. Okay, so number 6. So we are given, so this is number 6. Whoops, number 6. We have f of -7 equals 0. And we also have that the slope of f is -4/3. Okay, so in these instructions, what it's asking me to do, and 5. Okay, what it's asking me to do is it is asking me to write a linear function that have these particular properties. And so what we had done when we did these types of problem is we looked to see what we were given, and we labeled everything. So typically when we talk about a function, instead of having f of a number, we typically have f of x. And so what that tells me is that the x value in this particular problem is a -7. And then usually we take our x value, we pop it into something, we do a little bit of work, and a y value pops back out at us. Okay, well, so we have an x, we have a y. What letter does the slope always represent?
M.
M. And so I have this x, this y, this m. What I'm trying to do at the very end is write a function that looks like this. F of x equals y, no, nope, hold on. F of x equals mx plus b. This is my goal. And we know that this f of x is easily replaced with y. Well, I have an m, I have a y, I have an x. What I don't have is this b value. So I have to solve for that. So I'm going to say, okay, y equals mx plus b. I'm going to say 0 for my y equals m, -4/3. X is the -7, and then plus a b, which is what I don't know. So I'm trying to solve for b in this particular problem. Now, probably my guess is we're going to want a calculator right here, okay? So we're going to get 0 equals, when I do this particular multiplication, what number am I going to get? It's going to be like
28 over 3.
And that's going to be plus b, okay? And all I'm trying to do here is solve for b. So I'm going to minus 28 over 3 from both sides. And I'm going to get that b equals -28 over 3. And so now I'm going to look at what I have. I have an x value, I have a y value, I have an m value, and I finally have a b value. Well, what I really need in this problem is an m and a b, which I have. And so now I'm going to say, okay, well, I'm ready to wrap this thing up. So I'm going to come over here, I'm going to say, okay, f of x equals my m value, which is -4/3 x, and then my b value, which in this case is -28/3. This is my total and final answer. So think about that. Okay, we started out with an x, a y, and an m. We had to solve for the b value. Once we found that b value, we just popped everything that we had, our m and our b, into the slope-intercept form, essentially. Y equals mx plus b. Okay, so better on 6. That was 6.
So that we completely ignore the -7 in our answer.
Yes. Because when we write, think about it for 1 second. When we write slope-intercept form, don't we always write y equals mx plus b? And haven't we always just changed the m and the b? The y and the x are going to stay exactly the same. The only reason we need the y and this x is so that we can find the b initially. And then we say, okay, bye. We only care about the m and the b because those are the variables that are going to change in our problem. Okay. All right, so that was 6. So someone said 5. So let's back up real quick and take a look at 5. So for number 5, since it's a graph, I'm going to show it to us real quick so we can see it instead of me trying to draw it and write it. So number 5 looks like this guy. Okay, this graph over here to the right. And the question is, determine if this is a function, yes or no. And so the first thing that I need to do is look at this parabola, and I need to draw a vertical line through it somewhere. So bam, I can't obviously write on this, but let's pretend that my mouse is the vertical line. How many times is it going to cross through that particular picture?
1.
Just once. And so the answer to step number 1 is yes, this is a parabola. Or yes, this is a function. Okay, so now step number 2 says we have to determine the domain and the range. And then we have to express our answer in interval notation. And so if we look at this, again, our domain is just the x values, So we want to know how far left and right this thing goes. Well, it's a parabola. We've had lots of parabolas. And because it's a parabola and because these arrows indicate that it continues in this position forever, that the domain of the range is going to be all reals, right? All the way from the left or negative infinity all the way to the positive infinity. Now, as far as the range goes, the range is how far up and down this thing goes. So we can see that it starts moving right here, right? There's nothing down here. So we got to figure out, this is my lowest point. And so I have to say, okay, well, what's this y value? Because I'm only looking at the y values. And so I go up 1, I go up 2, I go up 3. Hey, look, 3, okay? That's where it starts. How far up does this thing go? All the way. Well, how do I represent all the way? Infinity. And so my range is 3 with a bracket because there's technically a line going through this, so it's a point, all the way to infinity. And now I'm done. So that's it. Yes, it's a function. There's my domain. There's my range. Finished. What do you think? Better?
Mm-hmm.
Okay. All right, so then the next question was question number 7. And on number 7, what we have to do is they give us a function, and we are trying to put it in vertex form, and then we have to try to graph it. And so let's clear all this out, and let's do just that. So they give us this function, q of x equals x squared plus 4x plus 3.
What
And
number is this?
this is number 7. And step number 1, so S1, step 1, basically it asks me to find the vertex. Well, since this is not given to us in vertex form, we can't find the vertex yet. And so this is the problem where we have to complete the square, okay? And so we'll take our function, x squared plus 4x plus 3, and we will do the completing of the square. And so the first thing I'm going to do is rewrite this as x squared plus 4x. Remember, I leave a blank spot. I put that whole thing in parentheses, and then my plus 3 is just hanging out back here. I come over here, I draw my scratch work, and I say, okay, I take my b value, which in this case is a 4. I divide it by 2, which gives me a 2. I put it in parentheses, and I square it, which happens to give me a 4. And so since this is a nice, neat positive 4, I put a plus 4. And since I added 4 over here, what am I going to have to do over here so that it turns out to be the same actually? Add it. Nope. If I already added
Subtract
it here,
it,
yeah, I'm gonna have to subtract it. That's right. That way those two would cancel each other out. And so now the completing of the square is technically done. And so this is my perfect square trinomial. And this is where I get to cheat by looking over here and saying, oh, hey, look, this is a 2 and it's squared. It's in parentheses. The variable they give me is an x. Here's my positive 2. It's being squared. It's all in parentheses. And then I say, hey, look, what is 3 minus 4? Well, that's negative 1. And so what happens is this right here is what we called vertex form.
So
And
when you're
once-
doing the problem, you want to always cancel out that last number in the parenthesis.
Yes, that's right. So once we get vertex form, we know that this number is my h value and this is my k value. And so we had already said that this looks like a positive 2, but really I always take the opposite of this. So when I pull that out, I'm going to bring out a negative 2. And I'm going to say, hey, this guy stays as he is, so I bring him down, and it's a negative 1. And so step 1, the answer for the actual vertex is negative 2, negative 1. Now, I'm going to pause there for 1 second, make sure that makes sense. Let you write that down. Any questions on how I got just the vertex? Okay. So then, step number 2, it says for us to find the x-intercepts. If there are any, express them as an ordered pair. So I can do that. So I'm going to just get a fresh page because I'm going to run out of space. So the problem that I had was x squared plus 4x plus 3. And when we need to find the x-intercepts, right, we're looking for points that are on this line. So we set it equal to 0. And once we set it equal to 0, that tells me that I'm going to have to factor. And so when I do that, I'm going to say, okay, well, I need 2 numbers that are going to multiply together to give me this 3 while adding up to give me 4. Well, how about 3 and 1? And then I have to solve each of these by saying, okay, well, that means that x plus 3 equals 0 or x plus 1 equals 0. And so when I get this done, I'm going to have x is negative 3, but I'm not allowed to leave it like this, right? I have to actually write it as a point. So negative 3, 0. So here's one of my x-intercepts. And then over here, I'm going to subtract 1. I'm going to get that x equals negative 1. But again, can't leave it like this. Got to write it as a point. And so these two together are my x-intercepts, negative 3 and negative 1. Okay, what do you think about that part?
What happened to my broken banana?
What happened to what?
Oh, I'm sorry. I didn't know my microphone was on.
Oh, that's okay. Okay, so any other questions on finding the x-intercepts before we scooch over to the next piece? All right, so then step number 3 says to find 2 other points that are not the intercepts and that are not the vertex. And so we're going to be starting again with our same exact function, and we need 2 other points. Does anybody remember the easiest one that I said that you can find all the time?
0.
0, yeah, because if x is 0, bam, bam, that just leaves me with this constant. So one of the points, without having to do any other work, is the, actually it's the y-intercept. But yeah, it's like x be 0. So there's one other point. Now, the next way, the best next way is to just pick a number. Pick a number that's close-ish to where we're going. So why don't we pick 1? Let's just say, what if x was 1? Well, I put a 1 here, and I put a 1 here, and I calculate. So I'm going to have 1 squared plus 4 times 1 plus 3. Well, 1
Well, I
squared.
thought you started at the vertex and picked 2 points around the vertex.
You absolutely can. That is a little bit better when we're doing our transformations, but you can do that. Let's back up and do that. So the vertex we got was what? -2, -1. So what if we picked, okay, hold on. Let me write that down because I'm running out of, I can't remember everything. I wish. The vertex was -2, -1. But here's what happened. Remember when we found the x-intercepts? They were -3, 0, and -1, 0. So technically, the numbers that are right on to the left and to the right of the vertex, they've already been picked. So we're going to have to pick something else. So we went ahead and we picked 0. So why don't we just go ahead and pick 1 now? Okay? But yeah, you're right when you said that. But we have to make sure that if we do that, we haven't already picked them as the vertex or as the intercepts, because that's not going to help us. So if we let x equal 1, we're going to have 1 squared plus 4 times 1 plus 3. Well, 1 squared is just 1. 4 times 1 is just 4. 3 stays 3. This all adds up to give me 8. And so if I let x equal 1, then I have 2 points, 1, 8, and 0, 3. And so now I have the vertex. I have 2 x-intercepts. I have 2 other random points. And now all that's left to do is actually graph these points. Do we need to look at that, or do we feel okay about that, or what?
Can you graph it? Because I graphed mine and it looks weird.
Sure. Okay, so 6, 7, 8, 9. Whoops. Okay. All right, so here's my graph. And the first thing I'm going to do is graph the vertex, which we said was -2, -1. So we're going to start at the origin. We're going to go left 2 and down 1. So there's that. And then we got the x-intercepts, which we said was -1, 0. So it's this point. And we said was -3, 0. So it's this point. And then the next thing that we got was the y-intercept to be 0, 3. So we start at the origin, we go up 3. And then the next one we got was 1, 8. So we go over 1 and up 8. So 3, 4, 5, 6, 7, 8. So like this. And since we know, okay, that somewhere in here was my x squared, that tells me right off the bat that I'm dealing with a parabola. So you can't just do this, right? A lot of us maybe just want to do that and call it done. We can't. We know it's a parabola, so we have to go ahead and just make it look like a parabola. So whoever said that they graphed it and it looked weird, did you see maybe what you did to make it look so weird?
Yeah, I had -1 instead of positive.
That'll do it. Okay, so there's the totally all of number 7. Any other questions or problems on number 7? All right, so then the next requested one is number 8. So let's take a look at number 8 and see what we have. So number 8 says, consider the function, and it gives me f of x equals x minus 4 squared minus 4. And so step number 1 says, find the vertex. Well, the way that this function is already written, it's already written in vertex form. And so I know from my formula that this is my h value and this is my k value. I also know that this looks like a -4. And so when I bring it out, I'm actually going to bring a +4. And then my k is going to stay exactly as it is. And so my vertex is 4, -4. Any questions on step 1? Okay. Sorry, I had to yawn. So step 2 asks us to find the x-intercepts. And so since this particular problem is not written out like an actual quadratic equation is, we have to do that, okay? And so what we're going to have to do, I'm going to erase the vertex because I think we should probably have that written down. So what we're going to have to do to find the x-intercept is we're actually going to have to solve this thing. Set it equal to 0 and solve. Well, I have to get rid of this first. So first thing I have to do is FOIL. So x minus 4 times x minus 4, and then I'll have another minus 4, and that whole thing will equal 0. So here I go. So x squared, I'm going to get minus 4x minus another 4x plus 16, and then my minus 4 is still there, and that still equals 0. And so now I'm going to combine my like terms. So x squared, these two guys together will give me negative 8x. These two guys together will give me plus 12. And that will still be equal to 0. And so now, since I know I'm looking for the x-intercepts, I know I have to factor. So I need two numbers that are going to multiply together to give me 12, while adding up to give me a negative 8. So let's do what? Negative 6 and negative 2? So when I solve these, I'm skipping a few steps. I know that I'm going to get x equals 6 here. So this intercept is going to be 6, 0, and this intercept is going to be 2, 0. And now I have two x-intercepts. Now, what are our thoughts about finding the x-intercepts? Okay, so then step 3 says find two other points on the graph that are not the vertex and not the x-intercept. So Sarah, I believe, mentioned, don't we start at the vertex and pick one up and one above? This is a perfect example of us doing just that. So what we're going to do next is we are given the vertex, which we know, or we got to be 4, negative 4. So let's let x equal 1 less than 4, which is 3, and let's let x equal 5, 1 more than 4. And then we will have two other points. And so if my function is x, let me start again. Oh, gracious. If my function is, I still am writing this wrong, x minus 4 in parentheses, whole thing squared minus 4, then I need to plug in a 3, and I'll get 3 minus 4, whole thing squared minus 4, and 3 minus 4 is negative 1.
Wait, why would you plug it into the original equation and not the one, the x squared minus 8x plus 12?
You could absolutely plug it into either one. As long as your arithmetic is correct, it will be the same exact answer. I just I personally have a habit of plugging it back into my original problem. That's the only reason.
Okay.
Okay, but you could do it that way as well. So negative 1 squared is 1, and 1 minus 4 is negative 3. So if I let x be 3, my point is going to be 3, negative 3. So there's an additional point, and then I'm going to let x be 5, and so I will plug all that in, and 5 minus 4, of course, is 1, and 1 squared is 1, and 1 minus 4 is negative 3. So if I let x be 5, then the other point that I'm going to get is 5, negative 3. And so now I have the vertex, I have these two additional points, I have my two x-intercepts, and so now I'm ready to graph. Okay, so let's graph it, and let's see what this thing looks like. So here will be my graph. Okay, and so my vertex was 4, negative 4. So 1, 2, 3, 4, and then down 4. Okay, so about right here. And my x-intercepts was 2, 0, and then 6, 0. So 2, 3, 4, 5, 6. Okay, and then the two additional points that I got was a 3, negative 3. So 1, 2, 3, 1, 2, 3. And a 5, negative 3. So 1, 2, 3, 4, 5, 1, 2, 3. Okay. And again, since the problem starts out with an x squared in there, I know that this has to be a parabola of sorts. And so even though I don't have a ton of points, I can draw a pretty good enough parabola. And now I'm done.
Can I ask a question?
Absolutely.
So is this the type of problem that when you find the y for the first one, for the first other point you're looking for, you just have to go 2 over like the opposite direction and it's the same y, but 2 more for your
Yes,
x, right?
that is correct. Yes.
Okay.
So if you as an individual want to do that, then yeah, you can do that on the test and that'll be fine. Okay.
Okay.
So when we're finding the two other points, can we always stick with the vertex? And if it's always stick with the vertex and just pick two other points that aren't the x-intercept? Like if
That
it's
is correct. Yes.
okay.
Yep, that'll work. All right, so this was, what was this? This was 8. Any other questions on 8?
No,
Right,
but if we can do 9.
Oh yeah, so I guess from the chat box, it looks like we just want to do the whole thing. So I guess we can do that. So if you guys individually, if you want to hang out with me for the whole thing, fine. If you're good and you're ready, then you're excused whenever you want. You don't have to ask, you can just go. So we'll just start with 9 and we'll work our way through until we're tired of it or until we're done. Okay?
Okay.
All right, so let's do 9. Okay, so this is the one with the creek, right?
Mhm.
Okay, so the first thing that you're going to want to do is you're going to want to make a picture. Okay, so it says that Tom's property, the back of Tom's property is a creek. So let's make blue. There's a creek. Okay, and he wants to enclose a rectangular section of his property to make some kind of a pen. Okay, a pasture, I guess. And
I have a
he has,
question.
yeah,
Is this the one where you said the whole thing is completely the same until you get to the fence or the feet of fence?
yeah.
Okay.
Okay, so he has 120 feet of fence. So let's jot that down real quick. 120 feet. And basically the question is, what is the maximum possible area of the pasture? Okay, so we know that over here is the creek, so we don't have to use the fence here. We know we need a rectangle, so let's draw a rectangle. And we know that when we draw a rectangle, this side and this side are exactly the same. And we don't know what they are, so we're going to call them X. Now, we're going to pretend, or we're not going to pretend, we're going to say I have 120 feet. I've used X of it here, and I've used X of it here. How much do I have left? Well, that leaves me with 120 minus 2X. So far, so good?
Mhm.
Okay, so now we also know that when we need to find the area of something, of a rectangle, particularly, that's length times width. So here's where our function is going to come, because right now we don't have a function written. We have to write that for ourselves. So we're going to have a of x equals, and we know that the length of this thing is going to be 120 minus 2x. We know that the width of this thing is just x. Well, we also know that we can't have parentheses, and so we're going to have to distribute. So we're going to have, okay, well, a of x is going to equal 120x, and then when I multiply that, I'm going to get negative 2x squared. So here's my function that I'm going to work with. Now, we had mentioned prior that when we are given a function, the first thing we want to make sure is that it's written in degree descending order, because that is going to matter. So I'm going to rewrite this as negative 2x squared plus 120x. So this is the guy. I don't need any of this other stuff anymore. This is the guy right here that I'm working with. And so we also mentioned, so I'm going to erase this picture because I want to write a few other things down. So we mentioned when we talked about these types of problems, this max and min business, all we're really trying to do is find the vertex. We're really just trying to find a point xy. And we know that there's a vertex formula that gives me negative, the opposite of b over 2a, and then f of that opposite of b over 2a. And that's still just my x and my y. We also know that the x value tells me how many, and the y value tells me how much. Now, in this question, we don't see that phrase exactly, but are you going to say how many area or how much area? What do you think?
How much?
Yeah, so we're looking for the y value of how much. Well, we know we can't find the y value until we find the x value, and so let's do that. So let's find the x value first. And so this is my a and this is my b, and so I'm going to take the opposite of my b value, which in this case is going to be a negative 120, and I'm going to divide it by the number 2 times my a value, which in this case is a negative 2. And again, I leave the top alone for the time being. I multiply these two guys together, I get a negative 4, and then I type this into my calculator. And so I'm going to have that negative 120 divided by negative 4 is going to leave me with a positive 30. Now, what are our thoughts on that so far? Any issues with this? All I'm doing is using that vertex formula, which you will have when you take the test. Okay, so basically, this x value is replaced with the number 30. And so what this y value says, hey, take the x value that you got and plug it back into your function. So instead of having all this junk right here, all this nasty stuff, basically what I have is f of 30. So I'm going to take the number 30, and I'm going to put it here and here. And so I'm going to say, to find my y value, I'm going to say a of 30 equals negative 2 times 30 squared plus 120 times 30. And then this guy right here goes right in my calculator. Negative 2 times 30 squared plus 120 times 30. And when I type all of that in, I'm going to get the number 1800. And this is my how much. And so since I'm asking for area, you're going to write 1800 square feet. And now we're done. That's it. So what are your thoughts? And someone mentioned, Sarah, I think you mentioned all the problems with the creek. Okay, and wink, wink, there's going to be one. It's going to be just like this. The only difference is going to be this number. Every single other thing you will do the exact same way. Okay, so what do you think about this one? Any further questions or problems on it?
long as we have the formula, I think I'll be okay.
Yeah, I think so too, because all we're really doing is putting in the formula. I mean, that's it. That's really all we're doing. So if you take a look at number 10, which is the one that we're going to do next, it's the same type. It's the same idea, really. It says the total cost of producing a type of boat is given by this particular function, where X is the number of boats produced. How many boats, okay, there's our clue. How many boats should be produced to incur minimum cost? Okay, I don't really care about the rest of that. I care about how many. And so because I see the phrase how many, I only need the X value. So here's the function they give me. They give me C of, go ahead.
So the difference with this type of problem, since it straight up asked how many and
Yeah.
you only need the X, it just means like you don't have to go back through and plug in for the X value.
That is correct. You're gonna get one number. It's gonna be much smaller than like our 1800, and we're gonna say, oh, this many, and now we're done. So the function they give me is C of X equals 25,000 minus 60X plus 0.04X squared. Now again, my advice is to rewrite this thing in degree descending order, okay? So I'm gonna just rewrite this as C of X equals 0.04X squared minus 60X plus 25,000, like that. And I'm gonna say, okay, well, all I need is the X value. From my formula, I know that the X value is found by just doing the opposite of B over 2A. And so this is my A, this is my B, this is my C. And so here I go. I'm going to say, okay, well, the opposite of my B in this case is going to be a positive 60. I'm going to divide that by the number 2 times my A value, which is 0.04. And the number 60 has to stay the same for the time being. And then I go to my calculator and I do 2 times 0.04, and that gives me 0.08. And so now I have this particular teeny tiny division problem. And so in my calculator, I'll do 60 divided by 0.08, and that'll give me 750. Now the question is, how many boats? Well, 750 boats. Done. And so we are looking for the key phrase, how many or how much?
So if it would have said how much, you would have done the F, like the Y problem.
Yeah, if it would have said, you know, if the problem, instead of saying how many boats to make minimum cost, if it would have said what is the minimum cost or how much money would I have to spend or something like that, then I would have to go back and find the Y value. But since it only says how many, I'm only looking for my X value. So don't overdo these problems. That's it. I'm done.
But if it says how much, you can't find Y without finding X first, so you
That is
do
correct.
both.
That is correct. Yes. Okay. All right. So if we take a look, then if you guys need to stop me, please do. Otherwise, I'm just going to keep going. Okay. So the next one then is number 11. And this is where we talked about, we have 2 different functions, and we're basically plugging it in based on our domain. So we have negative 4x minus 5 if x is less than 5, and we have 4x plus 3 if x is greater than or equal to 5. So here's what the problem looks like. And then step 1, whatever, 1 asks me to find x where x equals 5. The second one asks me where x equals 8. And the third one where x equals 3. And so what I need to do is I need to just look at each of these little values one at a time and ask myself, okay, well, if x was 5, which one of these functions am I putting it into? Well, is 5 less than 5?
No.
Is 5 greater than or equal to 5?
Yes.
Yeah.
And so that means I'm putting it into this one. So I'm going to have 4 times 5 plus 3. Well, 4 times 5 is 20. And then 20 plus 3 is 23. Done. Okay, Ashley, problem number 11, like the one that we're doing right now?
Yeah.
Maybe. So let's finish this one and then I'll show you what that could look like, okay?
Okay.
All right, so let's finish this one first. Okay, so the next one is 8. So then I say, okay, is 8 less than 5? No. Is
No.
8 greater than or equal to 5? Yeah. And so I'm going to, again, put it in the second function. So I'm going to have 4 times 8 plus 3. Well, 4 times 8 is going to give me the number, what, 32?
Mm-hmm.
And 32 plus 3 is 35. Done. And then, of course, the last one is if x were 3. And so I go up here and I say, okay, is 3 less than 5?
Yes.
Yeah. So I'm going to use this function for the first time. So I'm going to have negative 4 times 3 minus 5. Well, negative 4 times 3 is negative 12. And minus 5 is going to give me negative 17. Done.
Do you want us to write it out like that, or can we just put the whole thing in our calculator?
I would prefer to see it written out. Because let's pretend for just a sec that you type this into your calculator, but for whatever reason, you accidentally type, a 2 here. I don't know. Your answer is going to be something crazy, and I'm going to have no idea how you got that.
Okay.
And I would have to just be like, you know what? All this is wrong. Whereas if you write it out and you just mistype something, I'll be like, oh, well, they just hit a wrong button. No problem. Okay. All right. So someone wants to know, could on the exam, could there be a problem where the answer is actually undefined? Sure. Here's what that would look like. What if instead, I'm going to do it in orange so we know it's just fake, okay? What if instead this particular number, instead of saying greater than or equal to 5, what if it said 10 instead, let's say? And so then if my problem, let me get rid of some of this. If the problem that I had to try to figure out, what if it said, okay, that's enough. If x was equal to, let's say, 7. Let's just say. And so then what's going to happen is you're going to take the number 7 and you're going to look at the top and you're going to say, okay, is 7 less than 5? Is 7 less than 5?
No.
No. And then you say, okay, well, it's not this guy. And then you're going to say, okay, well, is 7 greater than or equal to 10?
No.
No. And so you're going to write undefined, just like that.
We have
No
one of
other-
those on Hawks, I believe.
Yeah, I think so. I don't think there's one on the exam. I can't remember. But if there is, all you have to do right is undefined. No other work is needed. Okay, better for 11? All right, everyone's favorite, number 12. This is the one where we have two, so we'll have f of x. We have two functions that we have to graph on the same particular line. Or not the same line, my goodness, the same picture. We're going to say if x is less than or equal to -2, and then we have 2x squared if x is greater than -2. Okay, so here's what we have. And what we need to do is we need to draw a picture, and we need both of these particular pieces to be on the same exact picture. And so I'm going to do one in red, and I'll do one in purple so we can see the difference. Okay, so the first thing we'll do is the red one. So we look at this. Before we do anything, based on the way that this looks, based on the fact that this is just x to the first power, this is going to be a straight line. And since this found out front is the slope, this is going to be a straight line that goes down. It's going to look something like this on my graph. And then we're going to look at the second one and going to say, okay, since this is an x squared, we know it's going to be a parabola of some sort. Okay, so far so good? Because that's the first thing you have to be able to realize is, oh, this is what it's going to look like based on this. So any questions on that yet? Okay.
That's where I've truthfully messed up before on some of them, is like I don't realize what it looks like and I go to start plotting the points and then I'm so confused.
So you can't see my face, but I'm winking at you. I'm winking at all of you, okay? When you see the problem like this on the test, the first line is going to be a line that goes down, and the second one's going to be a parabola. Okay, and if you notice, if you've actually done the work, they're all like that, right?
Mm-hmm.
Yeah. Okay, so what's going to happen is we're going to come over here, we're going to look at this side, and we're going to say, hey, look, the domain, so to speak, changes with -2. So I'm going to draw my little dotted line through -2, because I know on the left-hand side is going to be one function, and on the right-hand side is going to be the other function. That's what that number tells me. And so then what's going to happen is I'm going to have to make some X and Y charts. And so I'm going to make one for my red guy, and then I'll go back and I'll make one for my purple guy. And so what happens is we know that the red guy is going to be from here over. And so let's put a -2 in there first. And then how about, I don't know, a -3 and maybe a -4, because that's going to tell me what's happening around here. And so if I take the number -2 and I pop it in right here, that's going to give me -7 times -2 minus 14. Well, -7 times -2 is positive 14. And 14 minus 14 is big fat 0. And so I'm going to get the point -2, 0. And I'm going to have to erase this because I'm definitely not going to have enough space. So -2, 0. If I put a -3 right here, that's going to give me -7 times -3, which is a positive 21. And if I minus 14, that's going to give me a positive 7. And actually, for the sake of our time and for the sake of the space that we have, I don't need to worry about the -4. That's going to be enough. And so then what's going to happen is I have 2 points. So I have the point -2, 0. And so I will come over here and I will graph that point, -2, 0. And since this guy is that double inequality sign, I'm going to actually make a solid dot right here at -2, 0. And then I'm going to graph the point -3, 7. So -3, 7 up here somewhere. I don't know. And we already said that we know it's going to look like a line that's coming down. All right. So we can go ahead and we can just draw a line that comes down and stops right here at this point. Now this is supposed to be a straight line. Now, what are your thoughts on red guy? Red guy's done.
So you got your points that you start with for your problem from how the -2 gives, like it's given to you the problem.
Yes.
Okay.
So if this were, let's say if this were a -3, we would start at -3. Whatever this number is over here, that's where we're going to start. Okay.
Okay. So you do like -3, -4, -5.
Yep. All right. So now we're on to purple guy. Now this says if x is greater than -2. So we know purple guy is going to exist in this direction. And so I also know that he's going to be a parabola. So here is my x and y chart for purple guy. And we know that he has to be at -2, but because this is an inequality symbol that's open, we're going to have a -2. This point, whatever it happens to be, is going to be an open circle. We know that because of this guy. Well, what's some other points that are close to -2? How about -1? How about 0? How about 1? And since this is a parabola, I know it has to have a bend. So I want to make sure that I get some numbers that are negative, but also positive. Okay. So we're going to take this negative, these numbers, and we're going to put it right here. So if I take a -2 and I put it in there and I square it, that's going to give me a +4, and 4 times 2 is 8. Well, if I take a -1 and I put it in here and I square it, that's going to give me a +1, and 1 times 2 is 2. And if I put a 0 right here, well, 0 squared is 0, 0 times 2 is 0. And if I put a +1, then that's going to give me another 2. So these points that I have in purple, these are going to be enough. Okay, I don't need a ton, I just need a handful. And so I'm going to plot the point -2, 8, but it's going to be with an open circle. So I'm going to come over here to -2. I'm going to go up to 8. Let's just call it here. That circle has to be open. Okay, because we know that if we draw a different vertical line through this point, through x is -2, it can't hit 2 points. Well, it hits this guy already. We got to make sure this guy's open. That way, this whole entire thing stays a function. And so now I got this guy, so I plot the point -1, 2, so like this. And then I, of course, 0, 0, and then 1, +2. Now, we already said before we got started that it has to be a parabola. So even though these points look kind of weird, we know that it has to be in the shape of a U. So we'll start over here with our open circle. We'll come down, we'll hit these two guys, and we'll just continue. And we'll say, okay, there we go. And now this graph is what I would need to see as your answer. So all of this stuff, of course, will not be there. Get rid of some of it. But this graph is going to be your answer. Now, what are your thoughts on that? It's not difficult. It's just you have to pause for a second, take a breath, and do the work. And it's not too much work. And again, I'm winking at you with both eyes right now, okay? Because when you see this question on the exam, this is what your answer is going to look like, okay? Just the number, this little dotted line might be different. But your answer is going to look something like this, okay? I don't know. There's no other way for me to make that any more clear for you, okay?
So it'll be the same setup, just different numbers.
That is correct, yes.
Okay.
All right, so that's number 12. Any other questions, any other problems right now on number 12?
Good on 12.
All right, so then we get to 13. 13 is one, this is 13. We have r of x equals, wow, that's the worst r I've ever drawn. We have -4 times the cube root of x. And the question is even, odd, neither. Now, I want to say real quick, when you're doing this in Hawks, you're just going to click, right? There's going to be a circle here. You're going to click in one of them. Now, here's the thing. Let's say you click odd, I don't know, and you guessed and you got lucky. When I grade your exams, I look at your paper. And so if you just guessed and you happen to be right, but there's no work over here, I'm going to count it wrong. Because to me, you have a 30% chance really of guessing and getting it correct. But I need to know that you know. So we can't just guess and say, oh, good enough. You have to show me the work. Now, when we do this even, odd, and neither business, the way that we go about it is the first thing we do is we replace x with a -x every single time. And so then we're going to have the cube root of -x. And then our goal here is to decide if I replace x with -x and I simplify it, do I get exactly the same? Do I get the opposite, or do neither of those things happen? That's what I'm looking for. And it's cool because the word even starts with an E and the word exactly starts with an E. So if it's exactly the same, that's an even function. If it's the opposite, which of course starts with an O, then it's odd. And if it's neither, then it's neither. And so here we go. If we have this, the first thing we have to look at is just this piece. We have to say, okay, well, if I take the cube root of -x, do I know what that is? What is the cube root of a negative number? Well, it's going to be negative. And so what's going to happen is this little -4, which is negative, and I multiply that by a negative, this is going to be positive. So when I simplify this guy, what I'm really left with is the positive cube root of x. Well, that's what I ended up with. Here's where I started. Are they exactly the same?
No, they're opposites.
They're opposites. So they're not exactly the same. So they're opposites. So bam, number 13, odd function, done.
So wait, you basically just took like, can you, I don't know. I'm lost.
All right. So what if I just started again? So whenever the question asks you for odd, even, or neither, or X or Y intercept, and again, sometimes there's just no easy way. You just have to know that what you have to do is take the X value, replace it with with a negative X every single time.
Okay.
So the -4 doesn't change, this cube root doesn't change, but this X and this X are going to become negative.
Okay.
And then our goal is to simplify.
Okay.
Okay. And so we look at this and we say, okay, well, what is the cube root of a negative number? I know it's going to be negative because that means negative X times negative X times negative X. So negative times negative is positive, and then a positive times a negative is a negative. So I know that this is going to be a negative number.
Okay.
So what's going to happen is you have this, we don't know what number it is, but we know it's negative. And so you have this little guy right here being a negative number. This is already a negative number. What do you get when you do a negative times a negative?
A positive.
So then what's going to happen is this negative, whoops, hold on, I didn't mean to do that. This negative right here and this negative right here are going to multiply together to give you +4 times the cube root of X. And you say, okay, I've simplified as much as I can. And you look at where you ended up and you look at what you started with and you ask yourself, are they exactly the same? No. And then you say, oh, are they opposite of each other? Well, this one's a -4, blah, 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 and this is a +4. So yeah, they're opposites. And then you get to say, oh, opposite means odd, and now I'm done.
Okay.
Now,
Make-
we'll do we still have a few more, and I think that will kind of hit it home. So let's take a look at 14, okay? It's the same type of problem. Number 14 wants to know, hey, is this even, odd, or neither? And we're going to do the same thing. So we're going to be looking at the function that we're given, which in this case is g of x equals the absolute value of x over 4 plus 2. And so the very first thing that we have to do is have to replace x and negative x everywhere. So this becomes the absolute value of negative x over 4 plus 2. Okay, now we want to simplify. And so I say, okay, well, if I ask you, what's the absolute value of negative x? Well, we know that the absolute value can never be positive. So do you agree that the absolute value of negative x is the exact same thing as the absolute value of a positive x? Do we agree to that?
Yeah.
Yeah. And so what happens is when we go to simplify this thing down below, I'll do it in purple, we're going to say, oh, well, this actually equals, and we had just said that this guy is really going to be the absolute value of x. That's the only thing that changed. 4 didn't change, plus 2 didn't change. So here's what I ended up with. Here's what I started with. Are those exactly the same?
Yeah.
Yeah. So even function, done.
Okay, that makes more sense. Somehow, I guess I missed that entire part in your lecture.
Yeah, maybe. I mean, I don't know. But yeah, that's it. That's how we're going to determine if it's even or odd. Now, if you look at number 15 and number 16, now they want to know, instead of even or odd, we want to know what type of symmetry this thing has. Well, the even and odd business, it goes hand in hand with symmetry. And so what's going to happen is, let's take a look at, what is it, 15? Yeah. So 15, the problem I get is x plus y squared, equals -1. And so what I want to do, I kind of winked at you guys the other day and I said, hey, anytime you see y squared, that's kind of like a little sign that says, I'm a little special guy. And we had said that when we see that, our little special guy, because we don't see him very often, we know that he looks like this. And so what's going to happen is it's asking me what type of symmetry this thing has. And when we talk about symmetry, if I could fold this right here, wouldn't these guys be exactly the same? Yeah.
Yeah.
And since this is my x-axis, I know before I even do the work that this guy has x-axis symmetry. Okay, but remember, you're not allowed to just circle that and say, Amanda told me. You have to prove it to me. Okay, and so in this particular case, instead of replacing our x value, we're going to replace the y with a -y. So all we're going to do is say, hey, it's going to be x plus -y squared minus equals -1. And then we're going to simplify. And if I have -y squared, well, that's -y times -y, which is, hey, guess what? Positive y squared. So this becomes x plus y squared equals -1. Here's what I ended with. Here's what I started with. Are they the same? Yeah. And so since they're the same, and again, since we can kind of maybe visualize this in our head, we have x-axis symmetry. And again, the only time we're going to have x-axis symmetry is if we have a y squared. Okay, I'm trying to make it very clear so that when you see that, you know where you're headed. You just got to get there. Okay, is that better?
Mm-hmm.
Okay, so then let's take a,
So like on number 13, would it ever be a negative x already, like underneath the radical?
I'm gonna go ahead and say no.
Okay.
It's not. It's gonna be a positive x. Okay. All right, so 16 then. Same type of an idea. They're giving me y equals the absolute value of 4x. And they want to know if what type of symmetry. It's question mark symmetry. Okay, so now, before we do anything, I try to show you guys a couple of different ways. If this 4 wasn't here, don't we know what the parent function looks like? Don't we know it looks like this?
Mm-hmm.
And what type of symmetry does this guy have?
Yeah.
He has y-axis symmetry, so to speak. So again, we know where we're going. We just got to get there. Okay, so here's what we're going to do. We're going to say y equals, and we're just going to take this x value and replace it with a negative x. So 4 times negative x, but it's still under the absolute value sign. Well, inside of this is going to become negative 4x, the absolute value of it. But don't you think, or don't you agree, that when we take the absolute value of a negative 4x, isn't it going to be the exact same as the absolute value of a positive 4x?
Mm-hmm.
Yeah. And so here's where we end up, and here's where we started. And since these are exactly the same, this is what we call an even, this is an even function, so to speak. And we know in our mind that when we talk about even functions, it looks something like this. And so because of that, it has y-axis. So some advice maybe is look at your parent function in your mind, decide what that should look like, and then say, oh, I know it should look like this. I know it should have y-axis. Let me prove it, and then prove it to me. Okay?
Say we were on the test and we just knew from the parent function what it looked like, and we, for some reason, panicked about what to do. And we said,
Okay.
yeah, it's a Y symmetry, but
But
we
you
don't
didn't
show
give me
the
your
work.
reasoning, so probably half credit, okay? Because
Okay.
one of the things that comes along with being able to determine which is which is being able to mathematically prove things, right?
Mhm.
So if this, let's say this question is worth 4 points, then you would get 2 out of 4 because this would be correct, but this would not be correct.
Okay.
Okay?
But
All right,
then
now.
on 15,
Uh-huh.
we ended where we started, but it was x-axis.
Yeah, and that's the reason why is because, so if you take a look, let me erase some of this stuff. If you look back at that particular problem, it said, what did it say? X plus y squared equals -1. All of the problems that we have done up until this point have been y equals something or f of x equals something, and we've replaced the negative x, and that's been fine. This doesn't say that. This gives me a number. My y value is squared and it doesn't equal anything. This doesn't say y equals blah, blah, blah. And so because of that, it's a different type of a problem altogether. And the best thing that I have for you to try to remember how that is by saying, hey, look, this is our little special guy right here. We don't typically see him. And so because of that, he's flipped. That's the best thing I have for you to try to remember that.
Okay.
Because what would happen is if you were to put a negative x in here and totally leave this guy alone, then you're going to get something that looks negative right here, and together you're going to give me the word neither, which is going to be incorrect. So I don't know how much more plainer, and I'm not trying to be rude, but I can't make this any more plain. When you see y squared, it's going to look like this. And when it looks like this, it's always going to have x-axis symmetry. Okay? All right, so let's see, 17 and 18 are graphing. I want to skip 17 and 18 for, no, okay, we'll just do it in order. All right, let's do 17. Let me get myself back there. All right, so clear this out. We'll start again. So here's 17. And the problem is v of x equals -3, the square root of x plus 5. And on the outside, I have another plus 5. Okay. And so the first thing we need to know is what is the parent function here?
Square root of x.
Okay, so square root of x is the parent function. And in our mind, what's the basic shape of that guy? Looks like that. And what's the vertex of this parent function?
0, 0.
Uh-huh. Perfect. Okay, we need to know all of this from the get-go. And then, of course, if you happen to be looking at the review, you see that it asks you these questions in order. The test is going to be the exact same way. It's going to say, hey, does this thing go left? Does it stretch? Does it reflect? What's going on? So first question is, does it have a horizontal shift at all? Here's where I would look for a horizontal shift. So what's going to happen because of that?
Left 5.
Left 5. Okay, good. The next question is, does it stretch or compress? This is the number that I look, not this negative. Okay, some of us talked about that yesterday. Just the number. So since this number is a whole number that's greater than 1, what's it tell me?
Stretch 3.
That's 3.
Good. So stretch 3. Okay. The next question is there an x-axis reflection?
Yes.
So x-axis reflection, which means flips down, so to speak. Okay, wow, I'm getting terrible. My handwriting. Okay, next, a y-axis reflection. We haven't really seen one of these, but this is where I would look. Is there a negative inside right in front of that x?
No.
And so no y-axis business. X-I-S, okay. And then lastly, up or down? Well, what's this guy tell me?
Up 5.
Up 5. Now, the next thing I need to do after all of this is find my new vertex, because that's where I'm going to start. And so when I find my new vertex, I only care about the left, right, up, down business. So if I start at 0, 0, and I go left 5, and then I go up 5, what's my new vertex? Well, it's going to be negative 5, 5. Now, what are your thoughts about that? Because that's going to be the most important thing.
Good.
So now, once we get our new vertex, once we find that, then what's going to have to happen is we are going to have to pick our x and y values based on that. So I'm going to erase some of this so that we have room. Actually, I'm just going to start new. So since our new vertex is negative 5, 5, here's our x and our y chart. We're going to put our new vertex in there. However, hold on, I've already messed up. I forgot what my function was, and I went on the wrong screen. So it was negative 3 square root of x plus 5, and then plus 5. Okay, so when we had the square root, we said we can't just pick willy-nilly. We can't just pick, negative 4, negative 3. We want to pick numbers that make this nice. Remember me saying that? Anybody remember me saying that? So we have negative 5, 5 already. Now, I don't necessarily want to pick negative 4. Maybe I do, maybe I don't. I don't know. So if I put a negative 4 right here, what's negative 4 plus 5?
Positive 1.
Positive 1. Okay, can I take the square root of positive 1 relatively easily? Yeah. So let's go ahead and pick negative 4. Okay, we'll go back and we'll do that in a second. Now, if I put a negative 3 right here, well, negative 3 plus 5 is a 2. I don't know the square root of 2, so I don't want to pick a negative 3. How about if I pick a negative 1? What's negative 1 plus 5? Ooh, 4. I know the square root of 4. That's good. Let's pick one more. What if I choose the number 0? Well, that's not going to help. What if I choose 1? That's the square root of 6. That won't help. How about if I pick the number 4? So I've got lots of numbers here that I can choose from. Okay, now for the sake of time, I'm just going to tell you what these answers are going to be. Because I think that if you can pick these x values, you can plug it in. And I think we can calculate this, and I think we'll be fine. So if I choose, let's see. If I choose negative 4, I'm going to get a positive 2. If I choose a negative 1, I'm going to get a negative 1. And if I choose a 4, I'm going to get a negative 4. And so what's going to happen is now I have to graph these guys, and then it'll be done. And so if I draw my graph, and I plot my new vertex, which is negative 5, 5. So 1, 2, 3, 4, 5. So probably like here, I guess. And then negative 4, 2. So here. And then negative 1, negative 1. And then positive 4, negative 4. So something like this. Now, that just looks like nothing. Okay, but we already said at the beginning that we know that it needs to look like this. It was that dolphin jumping out of the water. Now, we know that this is my new vertex, so we know this is where the graph starts. That means there's no other graph on this side. It's only over here. So I'm going to draw through my points the best I can to make it look something like this. Now, it doesn't look exactly the same because it's been stretched and it's been flipped, but it has the same type of a shape. And so now I'm done. And so what are your thoughts on 17?
So basically, to find the new vertex, it's always how much you're going left or right and how much you're going up and down.
That is correct, yes.
Okay.
All right, so then we're going to do the same exact thing with number 18. Okay, so different problem, same idea. This is going to be, let's just say f of x equals, there's a 1 plus 2 times the absolute value of x plus 4. Now remember, I had mentioned we want our x term to come first because this confuses me the way it's written. So first thing I'm going to do is rewrite this. And since this number 1 right here is positive, it's just going to be plus 1. And so now here's what I'm really looking at, this guy. Okay, I don't care about this guy. Get him out of there. And so I look at this and I say, okay, well, first thing I need to do is list my parent function. Okay, so you're going to notice there's a lot of repetition. I'm doing the same thing over and over. So my parent function is absolute value of x. In my mind, I need to know that that's my v. Looks just like this. And I also know that its vertex is 0, 0. And so now I'm ready. And so I'm going to look at this and I'm going to say, okay, left or right?
Left.
Left. How many?
Left 4.
Okay, left 4. And then the next question is stretch or compress?
Stretch 2.
Perfect. The next question, any x or y axis reflections?
No.
So no reflections, okay. And then lastly, up or down?
Up 1.
Okay. And so now I'm trying to find my new vertex. And when I do that, again, I'm only looking at how far left or right and how far up or down. So if this is where I started, 0, 0, and I go left 4, so 1, 2, 3, 4, and now up 1, what's my new vertex? What's this new point?
Negative 4, 1.
Perfect. And so now I'm going to have to go in here and I'm going to have to find my x's and my y's. I'm going to put a negative 4, 1 in the middle. And the numbers around that I'm going to choose is going to be what? A negative 5 and a negative 3. And then I take each of these values and I plug them in right here and I do that calculation. And for the sake of time, I will tell you that when I do that, I'm going to get a 3 on both of them. And so what's going to happen is I come over here and I graph this. So 1, 2, 3, 4, 5. So I graph my vertex negative 4, 1. And then I graph the point negative 5, 3. And then I graph the point negative 3, 3. And then I say, hey, I already know from the get-go that this is supposed to be in the shape of a V. And so bam, there it is. Done.
Okay, so it also says to determine the domain and range of the original function.
Okay, so that's a little bit misleading. I don't like the word original. It wants you to find the domain and the range of the guy that you just graphed. Of this
Okay,
guy.
so not
This guy over here. Nope, not this.
Okay.
Okay, just this picture that you have. Because technically, this written is this picture. But it's much easier to look at a picture and find the domain and the range. And it's not talking about the parent function. Okay, it's talking about the function that you actually graphed. So it's
Okay.
going to be this guy in red. And so if I were to do this and I needed my domain and my range, so let's do that because I didn't even see that, to be honest with you. I overlooked it. So for my domain and my range, well, the domain of this guy, how far left and how far right is he going?
All reals.
All reals. And then for my range, that's my y values. Yes, the whole thing is being recorded. And then I'll upload it on Blackboard later. And so then what's happening is I'm looking at my y values. And so I say, okay, I start at the origin. I pop up 1. So this is the y value of a 1. And so I'm starting at 1. And how far up am I going?
Infinity.
And so my range is going to be from positive 1 to infinity. Done. So there's my domain. There's my range. So when you see that word original, it just means your picture. Okay, don't overthink it. Don't look back at my parent function. It just means what you made. All right, so there's my graphing. Okay, what do we think? 17, 18. Better? Any other questions? Any other problems you want to ask me? Okay, so I got it good. So that's good.
What was the domain and range on 17?
Let's see. The domain and range on 17. So what happened was, I don't think I'm going to be able to bring that one back. But when I drew my picture, it looked like this. We had 1, 2, 3, 4, 5, and I think it went up to positive 5. So here was my vertex, and then the thing looked like this. Okay, and it's a rough draft, of course. But if I need my domain or my range, I ask myself for my domain, how far left and right does this thing go? Well, how far to the left does it go? What's this value? That's a negative 5. And then how far right does this thing go? Infinity.
Infinity.
Okay, and so when I'm talking about my range, I'm asking how far up and down. Well, if I start at 0, I need to know how far down this thing goes. Well, based on this arrow, sure, it continues this way, but it also continues down. So how far down does this thing go?
Negative infinity.
Negative infinity. And then I say, okay, well, how far up does it come? Well, clearly it stops right here. What's this y value? A positive 5.
Okay.
Okay, and so there will be my my domain and my range for that 17. All right, so now we're going to look at number 19. And this is one where we are doing, this is this increasing, decreasing thing, okay? So I look at this, and the picture that they give me looks like something like this. I think, let's see, yeah, looks something like this, okay? Now, I'm not the best drawer, you guys know that, but this is good enough. There's a point right here. And so my question is, I'm looking at this and I need to know where it's increasing, decreasing, and constant. So here's increasing, here's decreasing, here's constant. So now this is what I know we struggle with. But remember, your eyeballs are right here. Okay, those are your eyes. Your eyeballs are only looking at this x-axis. And the vertex is the point where the graph changes directions. So clearly the vertex is right here. Okay, this is going to be the point -2, 0, let's say. And so as my eyeballs are moving along, la, 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 what's happening with this black line? Isn't it going down? And then as soon as I hit the vertex, oh, hey, as I'm looking, what's happening to my line now? Oh, it's going up. And so if I ask you, where's this line increasing? Well, I'm only looking at the x values. It's increasing from 2 to infinity. And where is it decreasing? Well, I started way over here. So it's decreasing from -infinity to 2. Where is it constant? It's not. And that's it. So what are our thoughts about that?
On the test, is that all you're gonna want us to do with this?
I'm sorry, say that again. I didn't hear you.
On the test, is that all you're gonna want us to do with these?
Yep, that's it. Yep.
Okay.
Okay, so now number 20. This is where we are going to be adding and subtracting and doing all kinds of things to functions. So we're going to have that f of x equals x squared plus 5, and g of x equals x plus 8. And so step number 1 asks me to find f plus g of -3. And step number 2 says f minus g of -3. And then step number 3 is f times g of -3. And then step number 4 is f divided by g of -3. Okay, so when we did this, this was yesterday, I believe, we had said that instead of an x, we have a -3. And it would be great if we knew what f of -3 was, because if I did, and I also knew what g of -3 was, g of -3, I could just add two numbers. And so that's what we're going to do first. We're going to calculate f of -3 and g of -3. So up here, I'm going to say, okay, f of -3 equals -3 squared plus 5. Sorry, guys. Somebody is making ruckus in the dog herd. Somebody's barking. Hey, no. Okay, so -3 squared is going to give me the number 9. And 9 plus 5 is going to give me the value 14. And so I know that f of -3 is 14. Any questions on that? So now I need to find g of -3. And so that's going to give me -3 plus 8. And when I add that up, I'm just going to get 5. And so now I know what f of -3 is, and I know what g of -3 is. And now all that's left for me to do is add, subtract, multiply, and divide these numbers. So I come down here and I say, okay, well, let me get rid of some of this so it's not as sloppy. If I look at this, they're asking me to add. And so I will do that. I will say, okay, well, f of -3 is the number 14, plus sign. G of -3 is the number 5. 14 plus 5, 19. Done. The next one wants me to subtract. So I'm going to have 14 minus 5, 9. Done. The next one wants me to multiply. So 14 times 5, which 70. And then the last one wants me to divide, 14 over 5. Now I can't simplify this any further, so that's it. Now what are your thoughts on that? Because that's literally it.
Those ones aren't too bad.
Yeah, it's not too bad, right? We just have to, take it slow and see what you think. Okay, so that was, let's see, what was that? That was 20. Okay, so we're now on 21. Yeah, so we are almost done. Fantastic. All right, so number 21. The question says f of x equals -4x and g of x equals x minus 2. And what I need to do, step number 1, is I need to find f plus g of x and its domain. I think it asked me that. I don't know if it asked me that or not, but I'm going to do that. And then step number 2 tells me I need to find f divided by g of x and then also its domain. And we're going to use the same problem. Now, in the previous problem, this was a number, and we put the number in, and it was great. But it's not a number anymore. And so what we actually have to do is go ahead and add those functions up as they are. And so we're going to take f of x, which in this case is just -4x, and we're going to put a plus sign, and we're going to take g of x, which is x minus 2. And now we're just going to combine our like terms. And so we're going to say, okay, -4x plus x is going to give me -3x, And the only whole number I have is this minus 2. So here's my new function. Okay, so think about that for just a second. Any questions with finding that new function? All right, now, we had mentioned when we studied the domain that when we find our new function, in order to find its domain, we have to kind of look back at the two functions that we brought together first. So when I do that, I'm going to look back here at f of x real quick. I'm going to say, okay, well, what is the domain of f of x? I don't have any fractions. I don't have any square roots. So the domain of this guy is all reals. And then I look over here at g of x and I say, okay, well, I don't have any fractions. I don't have any square roots. And so the domain is also all reals. And so then when I look back at this little guy, I don't have any fractions. I don't have any square roots. And so guess what his domain is? All reals. So I'm done with step 1. I found the new function. I found its domain. Any questions on step 1? I guess maybe I should ask, is anybody still here? Oh yeah, I still have a few of you hanging on. Okay, and so then number 2, same idea, okay, but it's a division problem. So I'm going to take f of x, which is negative 4x on top, and then I'm going to take g of x, which is x minus 2 on bottom. And for the most part, when you do this, you're not going to be able to simplify. So don't overthink it. Say, okay, there it is. Now, when I find its domain, I know that the mom and dad function up here is all real, which is great. But I know now that I have a fraction, and I can't let the bottom be 0. So I'm going to say that x cannot equal, x minus 2, excuse me, cannot equal 0. And that's going to tell me that x cannot equal the number 2. And so I'm allowed to have all the numbers in the whole wide world except for the number 2. And so this is where I'm going to say, well, here's my number line, here's 2. It's all these guys, it's not this guy, and it's all these guys. And so I say negative infinity to 2, union 2 to infinity. And this is my domain. And now I am done. So take a sec. Look at that. What are your thoughts? My throat's getting tired. I haven't talked this much at one time. Okay, so then let's move on. Let's take a look at the next one then, 22. Yes, this is that function composition stuff, okay? Yeah, and so let me get my computer to work out for me here. Yeah. 22. So we have f of x equals x to the third plus 4, and g of x equals negative 2x minus 3. Okay, and so the problem is I need to find f of g of negative 4. Now, the first thing I notice is fog. Remember how I don't like that? So I rewrite this so that I can visualize what I'm doing. And so now I don't care about fog anymore, so to speak. And so the first thing I'm going to do is take negative 4 and put it in g. Well, I can do that. Then I'm going to get some value. Then I'm going to take that whole value and put it in f. And then I'm going to be done. So here I go. I'm going to find g of negative 4 first. And that's going to give me negative 2 times negative 4 minus 3. Well, negative 2 times negative 4 is positive 8. Sorry, I don't need to have that plus sign there. Sorry. It's just 8, rather. And then when I minus 3, I'm going to get 5. And so g of negative 4 is just 5. And so this g of negative 4 business right here, it's kind of like it's not really there. And in its place, I'm just going to have the number 5. Whoops, that should have been black. I'm going to have the number 5. And so now the last thing I need to do is find f of 5. So I take 5 and I put it right here. So I'm going to have 5 to the third plus 4. And when I do 5 to the third, I'm going to get 125. And when I add 4 to that, I'm going to get 129. And that is my total, complete, final answer. Now, what are your thoughts on that?
Simple.
Simple. I love it. Okay. Let's see. Am I getting a chat here? I do. Hold on one second here. Chat things. Not so bad. Yeah, not so bad. Okay, so then let's take a look at then the next one, which I believe is 23. And so kind of the same idea here. We have f of x, and that's going to equal x squared minus 2. And we have g of x, which is going to be x minus 1. And so the problem, step number 1, is to find f of g of x, and then find its domain. And then number 2 is to find g of f of x, and to find its domain. And so now, again, notice, okay, pay very close attention, this is no longer a number. So I can't just plug a number in. So what I'm actually going to have to do is plug functions into each other. And so this is really going to turn into, because remember, I don't like the way this looks, f of g of x. And so what I'm going to have to do is take all g of x and put it into f. So I'm taking all of this and I am putting it right here. And so what that's going to give me is x minus 1 whole thing squared minus 2. Do we see that? First of all, that's the most important thing, is do we see that? So then what's going to happen is I'm going to have to FOIL this. So I'm going to have x minus 1 times x minus 1, and then my minus 2 is still hanging out. So x times x squared, x times negative 1, negative x, negative 1 times x, negative 1 times 1, positive 1, and then my minus 2. And then, of course, combine my like terms. These guys are going to give me a negative 2x. These guys are going to give me a negative 1. And so here is my actual new function. Okay, we're going to have to do this in 2 separate steps because I'm not going to have enough space. So there's my new function. And again, since it's asking me for my domain, I need to back up here, and I need to look at the domain of the functions that I started with. Well, if I look at f of x, I don't have any fractions. I don't have any square roots. So the domain of f is all reals. If I look at g, I don't have any fractions. I don't have any square roots. And so, of course, his domain is also all reals. And so once I look at my new function, hey, guess what? I don't have any fractions. I don't have any square roots. And so the domain of this guy is all reals. And so there's step 1, my function and its domain. Questions or problems?
No.
Okay. And so then basically what's going to happen is we're going to do step 2. And step 2 is going to be very similar, except step 2 is asking me to find g of f of x. Okay. And so we're doing it the same problem, but we're doing it in reverse order. And when we took notes on this the other day, we mentioned that order absolutely matters. And so what we're going to do now, instead of putting g into f, we're going to put f into g. And so I want to rewrite this, first of all, so that it looks the way I like it. So this is going to be g of f of x. And I'm going to take f of x and put it into g. So I'm going to take all of this, which remember, this is just an x. I scratched it out. And I'm going to put it right here. And so that's going to give me x squared minus 2, and then a minus 1. And then I'm going to combine these whole numbers, and I'm going to get x squared minus 3. And that's all I can do. And then I look back and I say, hey, look, all reals, no fractions, no square roots, domain is all reals. Done.
When I was doing the g of x in Hawks, I kept getting confused about putting the g into f. Like, for example, with this one, I would have tried to make it like x cubed minus 3. I don't know why.
So,
It's
well,
like combining the
my guess is you're doing multiplication. So when I
Yeah.
draw these arrows, what you could do is when you draw your arrow, go ahead and just cross over that x. Like, don't even let yourself see it. Because what you're doing is you're replacing that x with this whole entire thing, whatever that thing looks like.
Okay, and then it's
This-
just what was happening to the other x.
Exactly. And so since this
Okay.
guy is just x squared minus 2, guess what? It's just x squared minus 2. And then this guy's just a little negative 1. There he is. So if you have to, completely and totally get rid of those x values that you're replacing so you don't tempt yourself to do any multiplication. Okay? All right. Any other questions on 23? Because we only have 2 more to go. All right. So 24, this is p of x, and that equals the cube root of x plus 3. And the question is to find the inverse. So I need to find this, the inverse. And so we had 4 steps. And the first step was to replace x, the p of x with y. And then the second step was to take x into y, to take y and swap their locations. And then I was just going to solve for y. And so I have a minus 3. And I'll get x minus 3 equals the cube root of y. And then how do I get rid of a cube root? I have to cube it. And what I do to one side, I have to do to both. So that's going to leave me with y equals x minus 3 quantity cubed. Now remember, okay, this is also important. I don't want you to go crazy with this. Leave it like that, okay? All you had to do is get y by yourself. By itself, you did. And so finally, you're going to take y away, and you're going to replace it with the inverse, and you're going to say p inverse of x equals x minus 3 quantity cubed. And that is my final answer, and now I'm done.
Sweet.
Mm-hmm.
Okay.
Better?
Mhm.
Okay, so then let's do the last one. All right, so same idea. Obviously, we're still finding the inverse. The question looks a little different. So q of x equals 2x minus 9 over 6. All right, so you guys talk me through this. So what do I need to do?
Replace it with y.
Okay. Got it. Okay, next.
Switch the x and the y.
Okay. Ooh, hold on. My line got a little out of control. Okay, got it.
Multiply both sides by 6.
Perfect. Yep. So that gives me 6x over here. I'm left with 2y minus 9. Okay, now what?
Add 9.
Okay, so 6x plus 9. Okay, now what?
Divide by 2.
Okay, so I'm going to get y equals 6x plus 9 over 2. Okay, now what?
Replace it with your q of x.
Not just q of x, but q inverse. But you're right.
Oh yeah, that's right.
Okay. And then that's it, right? I'm done.
Mhm.
Whew, boy, that was a long math class today. All right, so there it is. So what do you guys think?
Worth it.
Pardon me?
I said it was worth it.
It was worth it, absolutely. It's hard when I don't get to see you guys. You know I hate that. Believe me, I hate it. But this is the best way I can think of for us to meet. So that's all I got for you guys as far as tests go. So if you still have lingering questions, obviously you have all day Thursday and Friday to get started, so to speak. So if you want, we can still, tomorrow's Thursday. If a couple of you want, or if one of you want, just message me. And if I'm not busy, which, not a lot going on right now, I can Zoom with you, but you have to let me know. Okay, otherwise I just am like waiting and waiting for something to happen, which isn't always the best thing. So anything else right now before I let you guys go? I'm parched and I'm hungry.
Tonight, right?
I'm sorry, I was talking. What was it?
Our support assignment is due tonight.
It is, yes.
Okay.
And actually, surprisingly, pleasantly surprised, several of us have already turned it in, and I've graded and I've given it back. So I appreciate those of you who have done that. So thank you. But yeah, it's due tonight, and the Hawks is also due. And I hate to, bombard you guys, but the way I look at it is this: it's not going to do you any good to do all of that if you've already taken and failed the test. So let's get you to do that work. That way, when you go to take the test, you're like, oh yeah, okay, that's why. Okay. And then I'm working on chapter 5 stuff today. That folder will be available to you later today. And if you want to poke around and look, you can, but you don't have to by any means. We're going to start that on Monday. Okay. Anything else, guys? The let's see, 6 of you who hung out with me all day.
I think I'm good.
Okay. That's all I got. If you guys need me later, message me. Otherwise, you know what you have to do, and you have the next 2 days in which to get it done. So let me know. I'll be here. Okay.
All right,
Yes,
thank you.
Lucas. Thank you, Lucas, and everyone stay safe. And if you have to go to the store, which I have to do it on Friday, please wear your mask, take gloves, take hand sanitizer, all that stuff. And I'll see you guys later. Okay.
All right.
All right. Bye, guys.